This conference will now be recorded.
Okay, hi guys. So I hope I'm audible. Please let me know if there is any issue in terms of the sound.
It is audible, sir.
Okay, so I will start with so whatever I have left yesterday. So we were discussing something called probability distribution. Probability. So this is something that we were discussing yesterday, and I told that I will start with something called binomial distribution. So binomial distribution is one kind of discrete or categorical distribution. So means the variable that we use here is a categorical variable. What kind of categorical variable? This is basically a 1-0 kind of variable. And the nature of binomial distribution will be heavily used in our prediction when we try to predict, let's say, that whether somebody will get a promotion or not, or whether somebody will get will click your link or not, or any kind of 1-0 decision where there is either you do something or don't do something, or whether either you there is no sound. Other guys can hear me? Yeah. So Abhinav, you probably check your volume. Yeah. So for this kind of distribution where there are two outcomes possible, one is 1 and another is 0. So anything that you mention as 1, another thing is 0. So when there is a stochastic process, when the random variable, there is a random variable called x, which can take these two values, then we follow that. I will say that this guy follows binomial distribution. How? Let's say one example is, let's say you are tossing a coin, and let's say this coin is a biased coin. It's not an unbiased coin. It's a biased coin, but the probability of coming heads is p, and probability of coming probability of getting a tail is 1 minus p. Okay, so let's say this is the situation, that if I'm tossing a coin and probability of having a head is p, and probability of having a tail is 1 minus t. So this is given. Now let's say that you are tossing for 5 times. The question is, what is the probability that exactly 3 heads will come? So this is the question that has been asked to you, that you are tossing it for 5 times. Each time the probability of coming head is p, the probability of coming tail is 1 minus p. Now you have done this job for 5 times. What is the probability that exactly 3 times the head will come? Let's try to answer that. So let's say these are the 5 tosses. Okay. What is the probability that in the first toss you will get head? I'm asking you guys, what is the probability that in the first toss you will get head p? Very well. What is the probability that you will get head in the second toss? Again p. Third toss, again P. What is the probability that in the fourth toss I will get a tail? 1 minus P, and so on. So then, see, each toss is independent to each other. One toss has no relationship with the second toss, whatever the result comes. Then what is the probability that you will get HHHTT? If each of these tosses are independent to each other, what is the probability that you will be able to see this whole series HHHTT? Okay, if that becomes tough, let's talk about this. Multiplication of all, very good, multiplication of all. Makes sense? So basically, P cube and 1 minus P squared. Now, this is one possible outcome where you have three heads. How many possible outcomes can be there where you have three heads? It can be TTHHH. It can very well be TTHHH. It can be THTHH, sorry. It can be HTTHH and so on. There can be so many, yes. So how many? If somebody do the maths correctly, it will be 5C3. Means there are 5 places, out of which there are 5 places, like 5 straight lines, spaces, and out of which you are choosing in which 3 places I will put my H. And that can be done in 5C3 ways. So basically the probability that out of 5 tosses you will get exactly 3 heads, that probability is coming up to be 5C3 P to P cube and 1 minus P squared. Now this is exactly what we use in. So just see in this situation what is given and what is probability. I am asking the probability of 3 number of heads given that there are 5 tosses and P is the probability of individual heads. So these 2 are given, these 5 tosses are given, and this P probability is given. These 2 things are given, and the stochastic component, the probabilistic component is these 3 heads. It could have been out of 5 toss, 2 heads or 1 head or 0 head. What is the minimum possible value, minimum number of heads that can happen in this situation? Zero. What is the maximum number of heads can happen? 5. So the value varies from 0 to 5, and I have asked you what is the probability of 3. Similarly, I am giving you another condition. Let's say in my class, the probability of passing is, let's say, P. Somebody takes my class course and then he passes the course. The probability is P. I'm asking you that out of 50 people, what is the probability that 30 will pass? Okay, so how do I answer that? If I just try to follow the same formula that I have written here, see, this 5C3 will become 50C30 in this condition, and then P to the power 30 and 1 minus P to the power 20. Why this? Why this? So I would strongly suggest, don't mug up the formula. Let's say there are 50 spaces like this. So out of them, 30 random 30 spaces will be P, and the rest will be 1 minus P. Rest 20 spaces will be randomly chosen 20 spaces will be 1 minus P. So then the sum multiplication will be P to the power 30 and 1 minus P to the power 20. And this combination can be obtained into 50C30 different ways. That's why that is the formula. So basically, given these two examples that I've just done here, binomial distribution will be saying that if there are n number of trials and P is the probability of success in each trial, then what is the probability that I will get n number of success? The probability is NCM P to the power m and 1 minus P to the power n minus m, and that's the formula, and we don't mark up the formula. I just shown you how from very scratch you will get the formula. Okay, so this is a probability. And why this is a distribution, probability distribution? Because it tells me the value. What is the random variable here? This guy is random variable, the number of success. This guy takes a value of 0, 1, 2. What is the maximum value it can take? N. And for each of them, I know the probability. Based on this formula, if I know this formula, for each of them, I know the probability. Can anybody tell me what will be this value? If I join the probability from 0 to, very good. So that is 1. Because that considers all possible conditions, all possible situations that can happen. If you join all of them together, that becomes up to be 1. Now, why this is applicable? Let me give you a real life problem why it is applicable. Let's say I am a bank loan manager and credit manager or something, and I have been given 10 lakh rupees is my portfolio. I have been given 10 lakh rupees. And I have been asked that you can give 10 1 lakh loans to the market. And you have to make profit after 1 year. If you don't make profit, your job is lost. Job is gone. Fair enough, you have to make a profit. And I know the probability of defaulting of normal people here, probability of defaulting is 0.05. Means 5% people will default. My question is, should I go with this kind of an offer? That if you don't make a profit, your job is gone. If you make a profit, let's make the other way also. If you make profit, you get 10% bonus of profit. Okay, or should I take this kind of a job or not? Other example can be like this, that let's say you have a service level agreement. Many various IT companies have service level agreements, SLS. So they say that if for every failure, X amount of money will be penalized. Every SLA agreement, whenever there is a breach, X amount of money will be penalized. Now, I have been asked that whether I should go for this kind of a deal or not. What is the probability that with this deal, I will make a loss or I will make a gain? Just understand this situation that I am giving 10 1 lakh loans. So, how many person can default out of these 10 guys? What is the minimum number of persons can be defaulting? 0. What is the maximum number defaulting? 10. Let's say m number of people defaults. Let's say m number of people defaults. If m number of people defaults, then what is the probability of n number of people defaulting? That is NCM 0.05 to the power m and 0.95 to the power 10 minus m, where n is 10 basically. This is the probability of m number of people defaulting. Are you with me? Now, if this many people this defaults, what is my loss? For 10 minus m people, I make, let's say the interest rate is around 15%. So I make 15k, 15,000 rupees is my profit for 10 minus m people. And for m people, they default. They actually don't pay back anything. They fly away. So I lose full 1 lakh, 100k. Or in other words, it will be, let's say, 150 minus 115 m. This much k. Let's check. Let's check whether I'm doing it correct or not. This much 1000 into 10 cm 0.05 to the power m into 0.95 to the power 10 minus m. This is the observation and this is the probability. This is how much I will make profit. It can be negative also, and this is the probability of making that profit. And now m varies from 0 to 10. So what will be my expected profit? I will do a summation from m is equal to 0 to m is equal to 10, everything. Now if this value is positive, then I will take this call. If this value is negative, then I will not take this call. Now the maths looks to be difficult. There are lots of equations that I'm writing, but in R programming it will be one line. It's just a one single line to write this 10 cm. This value, the probability value, comes in one line. This value comes in one line. So that is something that's basic binomial distribution. If you have any question, you can ask me. Okay. So then, if you have understood this, we'll go to the next distribution, which is something called Poisson distribution. I am a native. How 15 m's are okay? So the 15 m is coming from this thing that I'm saying that probably, let's say the percentage is, this is, let's say 15% interest rate. So 1 lakh rupees, if you have taken a loan, then 15,000 rupees is the profit. No, the interest is the profit for the bank. So Poisson distribution. Poisson distribution is again a discrete distribution. That means for it cannot take your x, the random variable called x, cannot take any value. Remember, here the random variable can take 0, 1, 2 up to 10. It cannot take 1.1, 2.2, 3.5. It cannot take. These are integer values it can take only in binomial. Similarly, in Poisson also it can take only integer values, but from 0 up to infinite. So there is no upper limit. Why is it used? It is used generally for count variable. So Poisson distribution is heavily used for when you write, let's say, trying to predict that how many followers will I have. If I spend, classic example is that this guy, this person, what is his name? Facebook. Have you ever tried to give any advertisement in Facebook? You just check that if you have made a page, and Facebook says that with 200 rupees of ad, I will get you 500 likes. Now this 500 likes or 200 clicks or 400 followers, these are basically counts, right? It will not say 200.22 followers or 111.32 followers. So it's not in decimal point, it can take only integer values. Now for these kind of variables, where the variable is a count variable, which is a discrete variable, which is not a continuous variable. So not all numeric variable is continuous variable. That's what I want to say here. So yesterday I was talking about discrete continuous, categorical continuous. So here these are discrete, categorical. So from 0 to infinite it takes. So for any count variable, it will work. It will work. So to give an example, let's say that Sachin's average in test is how much? Around 47, 48, I forgot. Let's say 47. So this is Sachin's generic average in an innings in test match. And somebody asked, after giving this information, somebody asked that what is the probability? What is the probability that Sachin will score exactly 30 runs? So the equation is, in this case, probability that x is equal to 30 given lambda, or I would say not x is equal to 30. Let's write it in a mathematical way. X is equal to small x. Small x is the realization. Capital X is the random variable. So capital X is equal to small x given lambda. Lambda is the mean. This is my mean. So in general, my average score is 47. What is the probability that I will score 30? So the formula for that is e to the power minus lambda, lambda to the power x by x factorial. So these one probably you have to mark up, because this comes from exponential distribution, but it becomes a little bit difficult to derive it. So I will not go into that. So e to the minus lambda, lambda to the power x by x factorial. So for example, in this Sachin's case, it is e to the power minus 47, 47 to the power 30 divided by 30 factorial. So that is the value. And if somebody asks you, what is the probability that Sachin will score up to 30? So if I ask you this, what is the probability that Sachin will score up to 30? What is the meaning of up to 30? What are the various scores that Sachin can score up to 30? Yes. So 30 and less, not 1 to 30, it is 0 to 30. As so from 0 to 30. So basically then, what is the probability? The probability e to the power minus lambda, lambda to the power x by x factorial. Do a summation from x is equal to 0 up to 30, and here your lambda is equal to 47. Get the value. So basically, this is called a cumulative probability. The cumulative probability, the total probability up to 30. So this is called a cumulative probability up to 30. Why cumulative? Because up to that point you are asking the probability. If you are asking the probability at that particular point, you will get the probability mass function, or basically the points probability. And if you are asking something that up to this, what is the probability, then I will get cumulative probability. If I ask you the same question, that what is the probability that Sachin will score at least 30? How will you answer that? At least 30 means 30 and above. So basically from e to the power minus lambda, lambda to the power x by x factorial, it starts from 30, goes up to infinite. So from 30 to infinite. No, 47 is the average. That does not mean he will not score a century today. So now this becomes difficult. I cannot do up to infinite. I cannot calculate up to infinite. So that's why I will follow Siddharth's example. I will do 1 minus less than 30. So what Siddharth did wrong is basically from 30 to infinite e to the power minus lambda, lambda to the power x by x factorial is basically 1 minus from 0 to 29, not 30, e to the power minus lambda, lambda to the power x by x factorial. So what I am trying to say, that probability that x greater than or equal to 30 is basically 1 minus probability x smaller than 30, or x smaller than or equal to 29. You can write any one of them. Okay, so if I calculate this much, which is calculatable, I can calculate easily this much. Now for a program, for a R, both can be done. Both are calculatable. There is no problem in terms of R to choose any one of the path. So let me just open a R file. Just 1 minute. Oh, thank you. Thank you, Pritam. Good idea, actually. So Pritam just told me that why don't you save the sheet, because yesterday this thing crashed and the sheet was lost. Thank you. Okay, so let's try and solve some problems. Can you see the problems? Okay, so let's try to solve them. A company owns 400 laptops. Okay, a company owns 400 laptops. Each laptop has an 8% probability of not working. Out of the randomly selected 20 laptops for your salespeople, what is the likelihood that 5 will be broken? Now think about this random variable. What is the random variable here? What is stochastic here? No, I'm not asking the distribution. I'm asking what is the name of the random number of broken laptops. Thank you, Siddharth. So number of broken laptops is the thing that is stochastic. What is the minimum number of broken laptops? In question number 1A, 0. What is the maximum number of broken laptops in question number 1A? Okay, read the question carefully once more and then answer it. The question says that you randomly select 20 laptops for your salespeople. You randomly select 20 laptops for your salespeople. What is the probability that 5 will be broken? 5 out of how many? 20. So the maximum number will be 20. The minimum number will be 0. Which distribution do you know which has upper limit and lower limit in terms of the values? What is the maximum number for Poisson distribution? So in case of Poisson distribution, the maximum number is infinite. So it is clearly not a Poisson distribution. Here the maximum number is fixed, which is up to 20. So that gives me an idea that it is a binomial distribution. Good. In a binomial distribution, two things are generally required. If you remember, in a binomial distribution, we write like P is equal to M, comma, N, comma, P, something like this. This is something that we require. But N is the number of trials, P is the probability of trial, and M is the number of success. So in this case, the trial means I will pick up a laptop and I will see that whether it is broken or not. What is N? What is N here? 20. I'm picking up 20 laptops. What is the probability of laptop being broken? 0.08. So then what will be the answer of 1A? Divans was waiting when I will ask this question. Okay, why don't you go for the second one then? So actually all of them you will go ahead one by one. What is the likelihood that they will all work? They will all work means nobody is broken. So 20C 0 and then 0.92 to the power 15. Avinath, check 0.92 to the power 15 or what? Yeah. So 0.92 to the power 20 and 0.08 to the power 0. So as Divans wrote, that is the correct answer. Because all are working. And what will be the case when all are broken? Anybody has a doubt, please ask me. Just because other people are answering doesn't mean that you will not ask me. Yes, Preeti. Nothing. No significance. So that is also a job of a person who does the data science, that I have to choose that what is good and what is bad, and I will only use the one that is required. Okay, let's go for question number 2. And Preeti will answer. Nobody will answer, please. Nobody answers. Preeti, please try, read the question. Question number 2. So it is saying that what is the probability that 7 or more numbers will be present? What is the maximum that can be present? 10. Very good. So 7 or more means basically then 7, 8, 9, 10. Right? Okay. So what is the probability of exactly 7 being present? Exactly 7 being present, what is the probability? Yes, very good. So you can do the same thing for 8, for 9, and for 10, and then add them up. That is one way. What is the another way, Divyans? I'm pretty sure that you are waiting for that also. What is the another way? Instead of calculating 7, 8, 9, 10 and adding them up, is there any other way? Yeah. So sometimes this cumulative probability, there is a function available in Excel, in R. You generally get a function up to 6, up to 7. What is the cumulative probability? You will get that thing. And if you get that function, you can just write 1 minus that. Okay. Okay. Now come to question number 4 probably. This is Poisson distribution. And you can try later all the questions. I will share this document. Those who is finding it difficult in answering right away can try it later also. I will share this document. Question number 4. So it is saying what is the probability that 26% arrives between 9:30 to 9:45? What is the minimum number of, what is the random variable here, first of all? In question number 4, what is the stochastic thing? Yes, number of arrivals is, what is the minimum number of arrival? 0. What is the maximum number of arrival? Infinite. Theoretically infinite people can come. So then I am pretty much sure by answering that this is a Poisson distribution. Okay. So now in 9:30 to 9:45, in an average, how many people come? In the time period of 9:30 to 9:45, in an average, how many people will come? 30, because 15 minutes, 2 persons per minute, so 30. It is asking me the probability x is equal to 26 when lambda is equal to 30. This is what it is asking, and I will put that in the form. Now, if somebody asks me more than 26 arrives, then I will calculate from 0 to 26 and then I will subtract it from 1. Fair enough? For B, you can try. What is the value of lambda in 4B? $240, and the rest is set. Okay, so that's all about some problems. Let me share another screen to show you how to, if I want to do it in R, what will I do? Just 1 minute. Okay, I have not shared the file with you guys before, but I can share it now. Just 1 minute. Hold for a minute. So yesterday's PDF is lost, Sandeep, but today I will do it. Just hold for a minute, guys. So I have shared a mail with you guys just now. It will reach in 1-2 minutes probably. Where this distribution.r file has been sent. This particular file, distribution.r, has been sent to you guys. Okay, so just check whether that if you have received the file or not. So here the questions are given that what is the probability that one candidate using random attempts gives 4 correct answers out of 12 multiple choice questions, each having 5 options and 1 correct. So if we are randomly answering and there are 5 options and 1 is correct, then the probability that I will be correct is 0.2. The probability that I will be correct is 0.2. So probability is 0.2. 4 and then size is equal to 10. That's, if I just run this is basically what I'm writing. This is basically 10C4, then 0.2 to the power 4, and then 0.8 to the power 6. That value is coming up here. So you just have to write d binom. D binom 4 comma size is equal to 10, and then probability is equal to 2, and corresponding probability you can get. And now if I ask you find the probability that one candidate gives at max 6 correct answer. At max 6 correct answer means from 0 to 6 up to 6. So I can just run this from 0 to 6, I can add them up, and it comes up to be 0.996. Or okay, it should be 12. I'm sorry, it should be 12. Yes, I'm sorry. So or I can just write p binom. The p binom gives me the cumulative probability. Up to that point, what is the probability? While d binom gives me that particular point's probability, p binom gives me up to that point what is the probability. So up to 6, including the value 6, the probability is 0.9. So see, this value and this value is coming to the same. So I can use p binom instead of running a loop. So what should I write if I have to ask, find the probability that someone gives 3 or more wrong answer? 3 or more wrong answer. That means from 3 to 12. That means if I just calculate from 0 to 2 and subtract it from 1, that will be my job. So 0 to 2 and subtract it from 1. That will be 3 and above. Sorry, it got hanged. So the probability is coming 0.441653 and so on. Now, probability of having 6 or less bugs in a script with average bugs in the script as 4. Now, bugs in a script will be a Poisson distribution, because see, the number of bugs can be from 0 to infinite. So it's a Poisson distribution. So it is asking what is the probability that you will get 6 or less bugs. If by chance it asked exactly 6 bugs, when average is 4, what will I write? I will write d poise instead of p poise. 6 comma lambda is equal to 4. So that is exactly 6 bugs when the probability is 4, when lambda is 4. And when it is asking 6 or less, that means up to 6. I will run. I can run 6 or more by either writing 1 minus, or I can write lower is equal to false. So any one of them. So this is 6 or more. So lower is equal to false will be making it 6 or more. Fair enough, easy. So that is how basically we can calculate the probability distribution of the probability values for binomial distribution or Poisson distribution. Now there is another kind of distribution which is left, which is called a normal distribution. Which is called a normal distribution. So let's talk about that. We are reaching 6 p.m. Anybody who wants, there is one person who had a problem. What should I do? Okay, so we are in, we can actually, so I will go 10 minutes extra, 10, 15 minutes extra, and then I will stop. Okay, okay. So I will go probably up to 610, 6.5, 610, and then I will stop. So I will just start normal distribution. So Q binom and R binom is generally used. So if you just can start, just 1 minute. Just 1 minute. So see, there are for any probability distribution, there are 4 things. I will just ask for help P binom. Okay. So when I ask for help P binom, there are 4 things that comes up in the help package. Okay. So if you see, one is D binom, which is the point, then P binom is cumulative. Q binom, if I'm not wrong, let me just check. Okay, Q binom gives quantile function, so the functional value rather than the exact probability. So D binom gives the density, P binom gives the distribution function, and Q binom gives the quantile function. And R binom generates random variates. So each of them has different jobs. R binom is something that we will use later, but D binom and P binom is generally what we use the most. So just hold for a minute. I will just check what is. Okay. So what I was, we were discussing about normal distribution. So normal distribution is our fast continuous distribution.
Sir, we can't see the
So
screen
this
now.
is our fast. Can you see
Hello?
the screen now?
No, sir, it's
Can you
not
see the
available.
screen?
No, sir.
Wait.
Yes, sir, we
Yeah,
can
I
see
hope
now.
it.
It's a pink.
Yeah.
Yes, sir.
Sorry. So continuous distribution, this is the first continuous distribution that we'll talk about. So it can take any value from minus infinite up to infinite, any value between this. And there are certain characteristics of of this normal distribution. There are other types of continuous distribution also, but these have certain characteristics. One is it goes from minus infinite to plus infinite. That is first characteristic. Second is that this guy has mean, median, and mode at the same place. Now, this particular characteristic itself gives this kind of a picture. See, what is the highest point of this value of this? So here in the y-axis, I'm plotting frequency, and in the x-axis, I'm plotting the observations, minus infinite to plus infinite. So before I jump into this normal distribution, let me talk about a little bit about something else. So yesterday I was telling that probability of x is equal to a particular observation. You get this value when it is binomial. You get this value when it is Poisson, because both are basically categorical data. Discrete distribution. The data is categorical data. So the distribution is discrete distribution. But probability of x is equal to x is basically number of x is equal to x by total number of observations, different kind of observations available. In a continuous case, this becomes infinite. So we cannot get at a particular point's probability. We generally do not get. We only get a particular points or a particular zone's frequency. So when I ask you to draw a histogram, yesterday we have drawn histograms. In a normal distribution, in a binomial distribution, the histogram looks like this. Something like this. So let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say there 9 is the maximum number, 0 is the minimum number. And here, so here these are x, and here I can either plot frequency or plot probability, doesn't matter. Any one of them I can plot. Generally we plot probability in case of display. But in case of any continuous distribution, we cannot plot the probability. So we plot frequency. That means if I take 100 observations randomly, then how many observations will be coming here? How many observations will be coming here? How many observations? The count we generally try to plot. And that count gives me a bell curve kind of a shape when I have a normal distribution. So let's say I have taken a sample of 1000 values from a normal distribution, and I have broken the minimum value have come up to be minus 200, and the maximum value have come up to be, let's say, around 1500. Now from minus 200 to 1500, I have broken this in hundreds. So minus 200 to minus 100, minus 100 to 0, 0 to 100, 100 to 200. I have broken into bins. And then I plotted the frequency, not the probability. I plotted the frequency, the count. That count will look like something like this. The ogive of the count, that means if I just join the headers of the bar chart, this particular line is called ogive. The ogive of the count will look like a bell curve. So that's how normal distribution generally comes up. So when I'm drawing this bell curve here, actually I'm drawing a histogram, and then I'm joining the top of the histograms. I'm joining the top of the histogram. And hopefully you have seen what is a histogram yesterday. So now, can you tell me that at which point the frequency is highest? The middle point. So this is the point which is where the frequency is highest. So that's why this is the mode. And you see that this is also the median, because 50% of the observations fall higher than this, and 50% of the observations fall lower than this. So this is also the median. And this is mean because the both side is symmetric. If both side is symmetric, then the center of gravity will fall in this line. So your center of gravity is at your middle point. You can stand straight only if your both side of your body is absolutely symmetric. So same thing happens here. So that's why the mean, median, mode are same, gives this particular characteristics, gives this same. Then what? Then another characteristics important is how the distribution will look like. So if this is my normal distribution, let's say, I'm not drawing it well, but what the heck. So let's say this is the frequency, and this is my x, or minus infinite, from infinite minus infinite to plus infinite. So for Pritham, the answer is that for continuous variable you plot frequency, for categorical variable you plot probability. Okay, so let's say this. Now this is the mean I told. So this is mu, let's say this mu. So mu, this side one standard deviation, and this side another one standard deviation. Within this range, this shaded area, within this range, 65% people will fall. So that shaded area is 0.65. That is a characteristics. It has been observed. So based on the formula of this particular OGIF, if you do a I would say integration, then you will get this thing. That let's say I have a normal distribution with mean 5. So mu is equal to 5, and standard deviation, or basically sigma, is equal to let's say 1. Then I'm saying from 4 to 6 in this range, from 4 to 6 in this range. No, don't talk about one tail, two tail yet. We have not come to tails here till now, Madhusmita. So again, hold your. So from 4 to 6,
Okay, sir.
around 65%, to be precise, it is 66.36%, or 2/3 people will fall in this range. So that is something that is a characteristic. So let's say, like in the previous one, I just told that from a normal distribution, I took 1,000 values. Okay, I took 1,000 values from this normal distribution I just told. Let's say I took 1,000 random values. Let's say your income of this India is normally distributed. Let's assume it is not, but let's assume that it is normally distributed. And the mean is, let's say, 5 lakhs per annum, and the standard deviation is, let's say, 1 lakh per annum. Then if I take 1,000 people randomly from India, then 666 people will fall between 4 lakhs and 6 lakhs. This is the meaning of the of whatever I'm saying here. Next, if I go ahead, two standard deviation this way and two standard deviation this way within this range. That means if 5 is the mean and 1 is the standard deviation, then between 3 and 7, 95% people will fall. And actually it is not 2, it is actually 1.96, to be very clear. So from 1.96 this left side and 1.96 right side, 95% people will fall. Similarly, oops, sorry. Just 1 minute. Okay, similarly, three standard deviation this side and 3 standard deviation this side. Within this range, 99.97% people will fall. 99.7. Okay, so just check the values. And then sigma this side and 6 sigma this side, within this range, 99.9997% will fall. So basically, we say that 3 in 1 million will fall outside this. So this particular range, that 6 sigma left side and 6 sigma right side, is called 6 sigma level of quality. When we talk about quality in this particular zone, I am saying this exactly. For example, let's say I am saying that this is my, let's say, medicine. I have created a medicine, and the medicine's job is to reduce your temperature, body temperature, paracetamol. So I am saying that the paracetamol quality is 6 sigma. That means that 3 in 1 million case, the paracetamol will not do whatever it is trying to do. In all other cases, it will be doing whatever it is trying to do. And I have to give a range. What I'm trying to do? I'm trying to do is reducing your body temperature with a mean of, let's say, 3 degree Fahrenheit. So whatever is your body temperature, I will reduce it 3 degree Fahrenheit with a standard deviation of, let's say, 0.05 degree Fahrenheit. So that means I'm saying from 6 degree Fahrenheit to 0 degree Fahrenheit, right? 6 sigma, okay, no, sorry. 6 sigma is 3.3. So from 3.3 degree Fahrenheit to 2.6 degree Fahrenheit, this much drop will happen. Anything in between this will happen with a probability of 0.999997. That is what I'm trying to say. That if in general the mean drop of body temperature after taking my paracetamol is 3 degree Fahrenheit, that means if you are 102 is your fever, it will become 99. 100 is your fever, it will become 97. So if average drop is 3 degree Fahrenheit with a standard deviation of 0.05, and I am assuring that it has 6 sigma level of quality, then I'm trying to say that 3.3 to 2.7 within this range, most of my cases will fall. How much most? 3 in 1 million will fall outside of this. Most people will experience a drop in their body temperature like this. So that is the basic characteristics of normal distribution. Some of the basic characteristics of normal distribution that we generally try to use. Okay, so let me go once more, easy way. I told you so airplanes, all the flights run in 12 sigma level of quality. So 3 in 10 to the power 12. 3 in 10 to the power 12 is the probability that anything will happen in a flight. So forget about 6 sigma. Okay, now just consider this. So what did I tell? If the mean is mu and there is mu minus sigma and mu plus sigma, in this range, within this range, 66.36, basically 2/3, will fall in this range. Then how many will fall in this shaded area? What is the area of the shaded area? Very good. What is this dotted area? Yes, Sridhar. Okay, thank you. What is this dotted area? Yes, it's 0.5 minus 1.3 because from mu to up to infinite, from mu up to infinite is 0.5. So this dotted area is basically half minus 1/3 comes up to be 1/6. How much is this dotted area? Same, because these are symmetric to each other.
That will also be the same, half minus 1/3.
Exactly, exactly. So these are symmetric to each other, that's why it will be same. Very good. Why don't you tell me those? This is mu. You told me that within mu plus sigma, this range, you only told me that this is 1/3. Then tell me how much is this dotted area from mu plus sigma to mu plus 2 sigma. From mu plus sigma to mu plus 2 sigma. See, remember, I told you guys that 2 sigma this side, 2 sigma this side. Yeah. 95% false, the whole range. From 2 sigma left side and 2 sigma right side of mu, 95% false. Then in only one side, if I consider, this is my mu and this is my mu plus 2 sigma. This shaded area is half of 95, which comes up to be 47.5. Out of that shaded area, this much up to mu plus sigma, up to here, the probability is 1/3. Then what is the probability here? It is 47.5 minus 33, comes up to be around 14.5%. No, because that 0.5 minus 2/3, actually 1/3, is the answer here. Here I'm asking something else. Just carefully check. Yeah, 0.95 minus 0.6636. Put a bracket and then divided by 2. Atul, you have to put a bracket.
Sir, this side you have taken the mu plus 2 sigma, then it is all total,
Yes.
it is 100, I guess. Means from
Yes.
that 100, this is 47.5 and this is the when subtracted value 100 minus or 47.5 minus 33, then it is coming 14.5.
Yes, so 14.5 is the answer, right?
Okay, means both the sides it will be the same.
Exactly. So here also, if I just take, let's say by chance, mu minus sigma and mu minus 2 sigma, this will also be 14.5.
Sir, one
Is
more
it-
thing is that means, yes, sir, you speak, then I'll ask.
Come again?
Yeah, the only thing I'm asking that sir means out of total means both the sides after the division, it is this side is 100 and this side is 100, and out of that 100 you
Yes.
made the calculation. Okay, sir. Okay.
No. So right side is 50, left side is 50.
Oh, 50-50, sir.
So see, this is 33.
Yeah.
This is 33.
Okay.
This is 14.5, and then this is 1/6. 1/6 means almost how much? 16, right?
Yes, sir.
So now 1/6 is how much?
Sir,
Oh, no, this is not 1/6. This is not 1/6. This is 5%. So this is 2.5%, and this is 2.5%. So 95. No, up from mu minus 2 sigma to mu plus 2 sigma. This range is 95%. So what is left outside? 5% is left.
okay.
In the two halves, it is 2.5 and 2.5.
Got it, sir.
Okay.
Yes.
So now these are some of the classic ones, but not everywhere you will get these classic ones. And for that, you have to calculate the probability at that particular point. So how to calculate the probability using R, that is what I will show you today, and that is where I will stop. Uh, uh, so let me just put R again. So the question here has been asked is that probability of a student scoring 75 when the mean of the class is 60 and the standard deviation is 10. See the mean. So what is exactly being asked? That scoring more than 75. This is being asked. But what is the probability that you will score more than 75? So let's say if it is a normal distribution, the mean is 60, the standard deviation is 10. That has been told to me, and it is asking me if there is one value 7 is there, what is this area? What is the probability above 75? That has been being asked to me. So now, how will I get that? This is 1.5 sigma, basically. And I do not know what will be the probability when it is 1.5 sigma. I know 1 sigma, 2 sigma, 3 sigma, I know. But 1.5 sigma, I do not know. So that's why in those kind of situations, I will use basically this function, which is P norm function. P norm does what? See, P norm gives me the cumulative probability up to 75. And I have done lower tail is equal to false. That means it will do 1 minus the other thing. So I have just wrote P norm. If I just write this will be the giving me the probability here. Mean is equal to 50. Oh, sorry, mean should be 60. Mean is equal to 60, standard deviation is equal to 10, and lower tail is equal to false. That itself gives me the probability. Now, just asking you, in a normal distribution, can you tell me what is the difference between these? Which one is higher? Out of these two, which one is higher? Why same and why the second one? Those who are answering the second one, why you are answering the second one? And those who are answering equal, why you are answering equal? Yes, because one single point's probability is 0. Irrespective of it is 75 or 73 or 71 or whatever, that single point's probability is 0 because it is a continuous distribution. So these are conceptual questions. Then the probability of a single point is 0. So that's why these two are same. That's why I will not think about, while writing lower tail is equal to false, I will not think about whether I should write 75 or 74 or 76. In the previous one, I had to think about that. In Poisson distribution and normal distribution, whenever I write lower tail is equal to false, I have to think about whether there is equal to sign, greater than is equal to, or just greater than. Because that 74 and 75 will give different answer there. But here it will not give separate answer. So that is something that you have to consider. Now the next one, probability of a student scoring less than less than 75. So lower tail is equal to true. That's the only difference. So I can calculate any probability irrespective of whether it is 1 sigma, 2 sigma. So whatever that 1 sigma, 2 sigma, 3 sigma things that I told there, doesn't matter if you have this code in your hand. So remember, I told that between 2 sigma, 1 sigma and 2 sigma, what is the probability? Let's say mean is 50. Let's say mean is equal to 50 and standard deviation is equal to 10. Then what is mean plus standard deviation? Mean plus standard deviation is 60. And what is mean plus 2 standard deviation? Mean plus 2 standard deviation is 70. In this kind of a situation, if somebody asks me, what is the probability between 60 and 70? No, it's not compulsory. It's not compulsory. That's default. Okay, lower tail is equal to 2 is default. So, if somebody asks me 60 to 70, I can calculate like the way that I have drawn the pictures and etc. But here I will calculate it in different way. I can just write this is 70. Okay, and then I copy it and then paste it like this and write 60 here, and the probability should come. So 13.5. So you are getting 14.5. I gave some wrong values there probably. So 13.59, 10.6 is the probability. So you can directly calculate it here instead of going there. So how to create random numbers from a particular distribution? So generally RUNIF gives me a uniform distribution between 1 and 3. Uniform means each value will have same probability of occurring. The probability of occurring this and probability of occurring this will have same probability. R binom. So randomly from a 5 observation, you are asking that if the probability is half, what will be the outcome? So 1, so 0 is the outcome that is coming up. So next time if I again run, some other value will come up. So out of 5, how many success? Randomly it is choosing. And let's say here I am choosing 12 numbers where the lambda is equal to 5. Let's say Sachin's average score is 47, and I'm asking create 12 random score for Sachin. In the next 12 matches, he will score this much. What will be the scores? So these are the scores, that is random number getting generated using these functions. RPoise, RBinom, RNorm will give you the random numbers. So if you want to create random numbers, you can use that. Why this will be ultimately used, this Poisson distribution, normal distribution, and linear and binomial distribution, will come to that slowly. But today our major focus have been that there are 3 types of distribution which is important for our study. Out of them, 2 are categorical, 1 is continuous. There are certain characteristics, certain formula for them which has been saved in the notes, and this is how using R you can find out. So one type of Gaussian distribution is normal distribution. There are other Gaussian distributions also available. So Gaussian is a master class. Okay, so this is where I will stop today. I will be saving the notes also, and I will be sharing the I will be sharing this